Good morning, good afternoon, good evening, everyone. Just going to wait another minute or two for everyone to get logged in, and we'll get started very shortly. Greetings, everyone. We'll get started in about 1 minute. Hello, everybody. Welcome to the 4th Z-Wave Alliance Virtual Academy's Webinar Wednesdays, coming to you every Wednesday. We've got a great agenda, wide variety of quality content and presenters. This week's event, of course, as you know, you signed up for it, is the Z-Wave 700 series, getting started using Z-Wave with Simplicity Studio. Next week on June 24th, same time again, Webinar Wednesdays, we're going to present strategies for successful smart home product design and manufacturing. That will be presented by our friends Duncan Chang, Joe Zhao, and Michael Bailey-Smith from Leaderson, one of the top OEM suppliers for the smart home. And for those taking notes, July 1st, that week, we will be taking a break and then coming right back at you the following Wednesday. So what were you doing in 2003? In 2003, our speaker started working with Z-Wave, and ever since he's been writing firmware for light switches, sensors, window shades, remote controls, and many other Z-Wave IoT devices. Known by his alter ego, Dr. Z-Wave, he maintains actually a very informative and useful blog, drzwave.blog, and you may want to write this one down, drzwave.blog. When he's not installing his own solar panels, Eric is a Silicon Labs FAE, where he shares his Z-Wave knowledge to help bring even more interoperable products through development and certification. Ladies and gentlemen, here's Eric Ryard.
Thank you very much, Mitch. As Mitch mentioned, my name is Eric Ryard, and I've been doing Z-Wave since 2003. I am a Silicon Labs field applications engineer now. I've been working for Silicon Labs for 1.5 years. So I'm here to help you bring your product to market. That's my job, so you can feel free to give me a call or call any of the other FAEs here at Silicon Labs. Today I'm going to be talking about the Z-Wave 700 series getting started. The 700 series is our newest Z-Wave chipset, and that came out over 1 year ago. So the software is very stable, the hardware obviously is very stable, and we're shipping volume product. This session is being recorded, and I'm going to go pretty fast, so you might want to refer to the recording later or send that off to some of your friends. It will be posted on the Alliance site, and you should be getting an email later with a link to the recording. With that, let's go ahead and get started. So the first question that you might have if you're going to go and start working on a 700 series chip is, how do I develop software on it? Because that's That's the main thing you're going to need to work on. So the first step that you need to do is to go to our Z-Wave or to the Silicon Labs website, click on Community and Support, then click on Software Downloads. That's going to bring you to the Simplicity Studio installation site, and depending on your platform, you're going to use either the Windows installer, the Mac installer, or the Linux installer. We support all of the major platforms. In my case, I have a Windows computer, so I'm going to be demonstrating everything on the Windows platform. So you would download that. Normally, you know, this is a live. Definitely, I'm doing a live demo here. So normally, I would download it, but it takes a good number of 10 minutes or so, or 15, 20 minutes for this to download and install. So we're going to skip over that part because I already have Simplicity Studio right here installed on my computer, of course. So once you get Simplicity Studio installed, the first thing that you're going to need to do typically would be to install or to plug one of these in. This is our wireless WSTK starter kit. It has our main baseboard, it has a Z-Wave chip on it, and has a little personalization board that has some switches and some LEDs that the sample apps like to use. You can either use USB or you can use an Ethernet connection. Either way, the nice thing about the Ethernet connection actually is that you can actually have the device at or the development kit at your office, and you're still at home, and you can VPN into your office and then launch, you know, work on the software at the office while you're still at home, since we're all doing a lot of work from home these days. I happen to use USB because it's right here on my computer. It's right here in front of me, and it's certainly reliable and definitely speedy.
Hey, Eric.
So
just one quick thing I neglected to mention, and I'm sorry about that, especially because you're going to go so fast. If you have any questions, on the bottom of your screen, there's that Q&A thingy. If you click on the Q&A thingy and type in a question, I'll make sure to be moderating, either ask live as we go or hold them to the end, but put the questions down as you go. Sorry, go back. Go ahead,
Yep.
Eric.
Excellent, great, thanks Mitch, forgot about that. Yeah, so I have about 35 minutes of content, and then we have plenty of time at the end for the Q&A as well. So the first thing you want to do is to plug in your Z-Wave development kit, and it's gonna look something like this, and it's gonna have your chip selected in it. By default, it should automatically pick the correct SDK that you want to use, the correct protocol that you want to use that's going to be for that particular chip. If for some reason it doesn't, what you might need to do is to actually install it, in which case you would click the download button, click the package manager, click the SDK tab, and because Z-Wave starts with the letter Z, it's at the bottom, and you would install the Z-Wave SDK, the latest version, and you would just click on install. That again also takes several minutes. So what I'm talking about here today is working on an end device. So it would be like a thermostat or a door lock or a light switch and things. If you were doing a gateway, you would want to also install the Z-Wave over IP gateway software that's down here. And then you might also want the Z-Ware, which is another layer on top of that builds on top of that. I'm not talking about those two particular things. We're going to work on end devices for today. So we have Simplicity Studio. It should automatically pick this up again. If it didn't, you've installed it. Maybe it still didn't do it. So then you just click on Manage, and you would select it here and then say OK. And then it would come up with this list of software documentation, software examples, and then actually a demo based on whichever chip you've selected. For example, if I select one of our other chips that also supports things like Bluetooth, Zigbee, and Thread, then you get a different list of software and documentation. But in our case, we're interested in Z-Wave, so we're going to stick with Z-Wave for right now. Another little handy thing is back in the day when I used to travel on airplanes, I often didn't have a development kit with me, but I still really like this feature of being able to filter down and look at just the software that is for the chips that I'm working with. So if you come over here and click in this little plus sign over here, and then type in ZGM, then you can enter any one of these parts in here, and then it will be saved in this list, and then it will select the software and documentation for that. So even if you didn't have something plugged in, you can just connect it right here or select it right here, and then you can get to documentation or open a project and things like that. But we're going to work with real hardware, definitely the way to go. We're going to start off looking at the different applications. So let me briefly talk a little bit about Simplicity Studio. It is obviously an Eclipse-based IDE, integrated design development environment. Familiar with a lot of other tools. If you've worked with one of these before, it should be fairly standard and look pretty familiar. There's two primary containers within Simplicity Studio. The first container is the workspace, and that's where you put a bunch of different projects. The workspace can be configured, or you can have multiple workspaces which will configure Simplicity in a different way. So for example, maybe if you're working with Bluetooth, you would want to have things configured. You'd put that in a different workspace than you would with Z-Wave, for example. And in order to switch between workspaces, you just click on File and set Switch Workspace. You'd select one of the other ones, and that would do that. From inside of the workspace, you then have multiple projects, depending on whatever project that you're working on. In our case, we're going to work on a door lock keypad sample app. Actually, one thing before we get too far, I want to remind people on the documentation, which is all over here. So all of the Z-Wave specifications, all of the command types of what's actually transmitted over the radio, they're all described down here in PDF files, and you can get to those that way. The other thing to do is to look on the end device, and the really important document to get started in is, of course, the Getting Started for End Devices. And that brings up this document, which is very similar to the roadmap for what I'm going to be going over on this particular webinar. So that again is, if I'm going too fast, start with that document and it'll get you started. So we're going to start with the door lock keypad. So I'm going to click on this button, and what Simplicity just did is it copied all of the necessary sample files into a new project within my workspace. So these are the files that are necessary to create this sample application. And we have 5 different sample applications. In order to pick which one you would want to start with, it really mostly depends on what the power source is for your particular device. A door lock, for example, is a frequently listening device, a FLIRS device, frequently listening routing slave. So every 1 second it wakes up and says, "Oh, does somebody want to unlock me?" And that's what the door lock keypad example is. If you're a sensor, probably battery powered, probably on a coin cell, for example, so very, very, very low power, you would start with sensor PIR. And if you're an always on device like a light switch or something, you might want to start with a switch on off. If you're not sure which one of these 5 sample apps to start with, that's what the FAEs are for. Reach out to one of us or file a ticket and ask, I have these things, which one would you recommend I start with? Again, to some extent, it doesn't matter. You can start with any of them, and then it can become whatever you need it to be. So we're going to go back to our door lock sample app. Typically, the first thing that you would want to do is to rename it, because if it's called door lock keypad underscore 23456, that's not a very descriptive name. You would just type in a new name here and call it anything you want. If from there, the next most common thing to do is then move all of the directory of this particular directory to some other directory. You can leave it in the default location, but you might want to put it into a different location. That's where your other GitHub or Git repositories might be. So it's a handy place just to say and do this. You want to do this like first thing is to rename it and move it first before you get too far into the project, and then things get a little messier. So the next thing we need to do is to do some configuration. You'll notice that we have under the source directory, we have our main application source code file, which has all the specific things for this particular project and all the source code that does things, but we need to configure a few things first. And inside config app.h is what we need to configure. The first thing you want to configure is the version, the revision, and the patch number. So if you were creating software and it was version 1.3.5, this first number would be a value of 1, then 3, then 5. And each time you release a new version of software, you would at least upgrade the minor version number. And this is all, this actually gets returned to the user in the version command class. So these are very important things to configure, and then you're going to increment this on whenever you have a new release. The next thing to configure is the type, the generic type and the specific type, and those are configured in the Z-Wave Plus device type document, and it tells you pretty much, based on what kind of device you are, whether you're a window or a thermostat or a multi-level switch, you'll have a different one of these. And this really tells when the hub that when you join like a SmartThings or some other hub, that kind of starts to clue the hub in, saying, hey, I'm a door lock in this case. So that's just getting started. There's more things to define as well. The Z-Wave Plus info type. This actually tells, for example, the hub which icon to use. Like, is it an on-off switch? Is this a water valve? It could be either one of those. This really starts to clue the hub in even more on what the device is. The next three parameters that need to get defined are very, very important. The first one is the manufacturer. And this is specific to your company. Every company that's developing a Z-Wave product is assigned a number. And that number is found in the Z-Wave class command.h file, which is down in the SDK, but this file is not that hard to find. And you can see that all of these different companies have their own 16-bit number. So you should already have it. If you're a brand new company, brand new to Z-Wave, then you will get one of these assigned by the certification group at Silicon Labs. So you definitely have to change this value. The next two values are, again, 16-bit numbers, but the combination of these three numbers creates a unique fingerprint for your device. When your device joins the hub, it's going to get these three numbers and say, oh, I know exactly what that device is and how to control it, what it looks like, and all those kinds of things. These two numbers have to be unique throughout your company. So you can't have any other device, whether it's a door lock or whether it's a light switch or whatever, you can't have any other device that has the same two numbers. Usually people have a wiki page or a Confluence page or some sort of shared document somewhere that says, this is the list of product types and product IDs and what product they go with. There are a lot of other things that need to be configured in here. We're going to skip over most of those and come down to the last one down here, which is absolutely the most important one to configure. This is the one that people get wrong, and they call me and they say they have their board, they're plugged it in and they've hooked it up and they can run their code, but they can't join a Z-Wave network. And the first question I always say is, what did you set app frequency to? And they say, oh, we didn't change that. And that's a problem. So all of the regions in the world have their own frequency. Again, so Z-Wave is in the 900 megahertz band. So in Europe, we're at 868. In the US, we're roughly 908 megahertz. In other parts of the country, we're at 920 megahertz and other different frequencies. But every region's a little bit different. So if you don't have the correct region assigned in your device, you can't talk to it, and it will be talking on the wrong frequency, and you won't know it. So first thing I'm going to do is change our config app region to be the US, because I'm sitting here in the US. Next file to update is config RF. There are only 2 numbers inside of here, and those 2 numbers we have a very extensive app note that goes through exactly how to set these numbers up. They, you only change these when you have your own product with your own antenna and your own PC board, and you're ready to go for regulatory approval, which in the US would be with the FCC. You follow the app note and it will tell you, help guide you on what these 2 numbers are supposed to be. So we definitely need to do that as well. The next step is to define a set of keys, public and private keys for this project. And these are unique to just this project. And the reason you need this is that you have to support over-the-air firmware update. Super handy feature. Everyone definitely, and you're required under certification now to support it. The advantage is that the over-the-air update firmware file is both encrypted and signed. So no one else can reuse it, and no one else can download anything other than the files that you guys create using these keys. In order to, we have a really good knowledge base article on how to generate this particular, these files. So if you do a search for OTA of end device or OTA 700, you'll find this on our website. And it goes through the details. Looks a little bit complicated, but I've actually uploaded 2 tiny little script files that do exactly what you need to do in order to create the keys first, and then program each and every device with the keys. So the keys are very important for over-the-air update firmware update. So you can't do it unless you install your own keys. And again, this key is burned into the flash for every single device of this particular project. So each set of keys is unique per project. The next thing that I want to do is we're going to click on Properties of the Project, and we're going to go to the C build, the settings, and the symbols. And what I'm going to do is I'm going to change this disable USART to be debug print. And then we're actually going to take the next one and delete it. The reason for doing this is that all of the application framework and the sample applications print out all kinds of handy debugging information out the UART. And the UART is, again, just a handy thing for debugging purposes. You can add little commands, in either direction, and you can do some really great stuff. It does make life just in general a lot easier. So you want to do that. So we'll click OK on that. So now we've got the debug print ready to go. One more thing that we want to configure is this file called board.c, if I can get it to open. So board.c is, you typically, you will copy this, when you have your own board with its own pinout, you'll copy this into the source directory typically. What this file does is it defines what pin on the chip is connected to which LED, which switch, which reset buttons, whatever else, SPI bus, whatever other things are connected to on your particular device. But what I want to point out in this particular file is the very last thing at the bottom of the file is what's called the default handler. And there's not a lot of things to point you that you really need to do this, but this particular handler is super important because the ARM processor has a lot of what are called exceptions. So if there's a hardware bus fault, or you try to divide by 0, or the chip branches into the weeds, or something basically goes wrong somewhere, it's going to call this default handler basically like an interrupt service routine. This is exception processing. And so what we have in the sample app is this little routine that toggles an LED on and off. So you can tell pretty quick when things are broken. on a development kit, but that's not what you want for production. When you send your device out into the world and customers start using it, you need a very, very bulletproof version of the default handler. The typical thing that you would do is that you would store some information on how you got into this default handler into what's called the user data page in Flash. That one page does not get erased when you do a reset of the chip in order to get in order to enable debugging again. So you'd write some data in there, and then typically you would do a watchdog reset and start over again and try to clean up from whatever failed. So again, you're going to copy board.c into your project as well and make some changes to that. So now we have we have our project ready to go. But before I want to before I compile it and make it work, one of the things that we want to do is to get the DSK, as it's called, which is also known as the QR code for the chip, which is a Z-Wave Smart Start requirement. So this is the DSK. You can get it directly out of, and it is specific to each chip. Each chip has its own DSK. The first time the chip powers up, if it doesn't have one of these, then it will create one. And each time it will be unique. Once it's created one, then it locks that down forever, and that device lives with that number forever, more or less. I mean, you can erase it, but pretty much it's locked forever. The important thing is that these are the 5 digits that you need to enter in the PIN code in order to join the Z-Wave network. This is the entire QR code, which is the ASCII representation of this particular pattern, and which contains the 40-digit DSK. So you would want to write that down or print it out or whatever you might need to do in order to join the Z-Wave network. In my particular case, we're just going to start debugging right away. So I'm going to click on the debug icon. Immediately the chip or the Simplicity Studio starts compiling all of the code. And the debug or the door lock sample app is one of the larger ones, so this takes a little bit longer. But you'll see that it only really takes a few seconds for it to compile all the code. It's not like we have to compile a huge giant pile of software. Much of the code is in the library, in the Z-Wave library. So there we've finished compiling the code. Now what's happening is it's actually creating the OTA file, encrypting it and signing it. Just finished that. Now we're going to tell it which developers kit to download it into, and it's actively downloading it into my little board right here. And what we see is that we've started out debugging, and we're ready to single step and try out our code, but we're at this function called main, which is pretty typical actually. But the problem is that in Z-Wave, in our sample application code, there is no main. Main is over in FreeRTOS, which is the main part of the Z-Wave SDK, the Z-Wave library. So that's in compiled code that we don't have the source code for. So in order to fix that, what we want to do is we want to go back to our project, and we're going to click on debug configurations. We're going to click on configuration. Instead of stopping at main, we want to stop at application init and say, oops, we want to apply that and then close it. Now we're going to debug. Same thing. You notice that in the way that Simplicity Studio comes up by default is it always tries to remake the files no matter what's changed whenever you go to debug. But you saw it didn't have anything to do. That's configurable. Whether you download every time is configurable. Lots of things in Simplicity Studio are configurable. So now what we see is that we've stopped at application init, which is where we wanted to stop. We're in our door lock keypads file. We're sitting right here ready to go. You can click on single step. We can single step over various instructions or see source level. You can see the disassembly over here. We can look at registers. If I click on this again, then registers in the processor will change. We can watch the variables. We can look in memory. You can set watch points. You can set breakpoints. All the good things with the typical debugging in a typical modern debugging environment. Vastly superior to our 500 series where things were much more difficult. So that's the debugger. When you're done with the debugger, I usually like to do a disconnect that cleanly pulls Simplicity Studio and lets go of the Z-Wave or the WSTK. One of the other interesting things that we have with Simplicity Studio is called the AEM. So we can profile this as an energy profiler, which again will double check and build the code if it thinks that it needed to, and then download it again, even though it doesn't really actually have to change anything. Again, all that kind of stuff is configurable, but it only takes a few seconds. So what we see here, this is basically an oscilloscope, and what it's doing is it's measuring the current that my Z-Wave chip is drawing second by second. And these tall spikes here, if you look at this, these are all exactly 1 second apart. And that's the frequently listening routing slave device where it's waking up once a second, very briefly listening and saying, does someone want to talk to me? Nope, I'm going back to sleep. So that's what it's doing there. If I tell it to wake up, then you can see that it goes and it uses more power up closer to 10 milliamps. And then it will go right back to sleep after a few seconds. So very powerful tool. You can also enable the C code tracking, so you can actually see what code is being executed at different times. Not super handy because at the end of the day, the radio is the big power draw. So anytime the radio is on and anytime you're transmitting, that's when you're using most of the power. But the C, it also helps debug and figure out what's going on in there. So when you're done with that, we can click end session. We don't need to save the data. And we're going to close that application as well. All right, so I did mention that one of the things that you need to do is that config_rf project, and that requires running what's called rail test. And I'm going to very briefly run an example of rail test right here. So again, it's just like the sample app. We run the rail test. And that takes a few seconds for it to come up. We can ignore that warning. Rail test is our tool for working with all of our radios. And our radios are software configurable. They're software defined radios. So there's a zillion different things that you could configure in here. The fortunate thing is that we actually don't have to configure anything. You can just click on generate and it will generate the project for rail test. And then you can just say, hey, download this into my SDK. That does take a few seconds or a little longer than I would like to go through, but you would just click on generate, then just click on download and rail test is ready to go. Then you follow our app note and it will tell you how to fill in those two defines for your particular project. The last thing that I want to point out that you really want to do, Mitch briefly mentioned my blog. This is the entry to my blog. I've been doing this since the beginning of 2017. So, and I've been posting roughly once a month on various and sundry topics, mostly recently about the 700 series, because that's what I'm working on for the most part. So I have this one entry here that goes through the GPIOs and what they're kind of like best used for. And some of the pins, you really only want to use them for certain things, in particular the debug pins. And I also have another discussion, another blog entry about the debug pins, and you definitely don't want to do this. I have several customers who created a custom set of test points that they would then wire the debugger up to. And as you can imagine, this just is not a very reliable connection. A reliable connection would look like this. Nice, simple little connector. You don't even install the connector on every production unit. You just solder it into the ones that you need to debug. Notice that this connector is in fact really small. This is a 2032 coin cell. Again, it's tiny, and it's only a fraction of that size. So you can't tell me that you can't find somewhere on your PC board, like under the coin cell, where you can squeeze this connector in. Again, you don't need it during production. You would only use it during debug. So those are that's my talk. We're ending basically right on time, and I believe Mitch has some questions coming in, and I'm going to stop sharing my screen, and I'm ready for your questions, Mitch.
Excellent. Thank you, Eric. That was very insightful. And we got a bunch of questions. So first one actually from our pal, David Seymour. And he asks, yeah, right,
He's one of our FAEs.
Yes, yes, he is. So a question, can the same antenna be used for all the different regions?
Yes, typically yes. So the 700 series, and on the 500 series, we required what's called a SAW filter. So the hardware had to be very region specific. So, and because the SAW filter had a fairly narrow range, the 700 series doesn't need that, that SAW filter. We were able to do a sufficient amount of filtering digitally on the chip itself. So it does take a little bit of balancing for the antenna, but usually your antenna will have enough bandwidth that it would cover all the way from the 868 band up to 920. Obviously, you'd want to have like a golden zone of wherever your biggest market is. I mean, if your market is primarily the EU, maybe you would center it on the EU and you'd be able to do the US, and maybe the range is just a little bit less. But again, RF antennas are definitely still a black art, and there's a lot of tricks there, and there's experts out there. Highly recommend some folks. If people want to ask, I can give you some recommendations.
And that's the beauty of the module, isn't it? Okay, it is. So we've done the work and the testing for you. So we have another question that says, if I bring all my devices from the US and bring them to Malaysia, would they still work?
Typically not. So that's the thing. You would need to usually buy them in a particular region. Technically, with the 700 series, you could do an over-the-air firmware upgrade and convert one to the other, but I don't know of anyone who's done that yet. And that's a very unusual use case. So plus, and the other challenge is that when you go, for example, from the US to Malaysia or something, the power systems are different. You 240 volts versus 120 volts. And typically you would need a different device.
Okay, good answer. Let's see, one from Gerardo Castillo. He's asking, hi, and thank you for this very useful session. At our company, we design custom solutions that will have very small numbers of units, frequently under 100 pieces. What is your recommendation in terms of getting a manufacturer ID? Is there a generic one, or do we need to get a manufacturer ID regardless of volume?
You would still, it's a little complicated. I think we'd have to ask a few of the right people to really completely get exactly the right answer. But my suggestion would be you should be able to do to get a manufacturer's ID anyway for your particular company. And you would, even though you're only going to make a few hundred devices, you would use the same manufacturer ID across all of the different devices that you do. So some design houses have their own manufacturer's ID, and then they use a contract manufacturer to build the device. Actually, almost all of the Z-Wave brands that are out there are all manufactured by a contract manufacturer as well.
Is there a particular cost assigned to getting a manufacturer ID?
No, that's free, so you can do that. So there's a lot of different moving parts. So you do at some point need to join the Z-Wave Alliance, and there's some costs associated with that. If you need to get your device certified, well, you would need to get your device certified. So there are some costs associated with that. The certification is all described on the SciLab's website, and there's a whole section, whole page just on certification, and there is a document that as a PDF file of all the fees for all of that.
Right, so in line with that point that you made on certification, Gerardo asks, could you please describe the certification process for a product that uses a Z-Wave module as a part of a commercial product and does not modify it in any way?
You still need to go through Z-Wave certification, and so that would still be required. And then you likely are still going to need to go, at least in the US, you would still need to go through FCC certification, even using a module, because you're still going to put your own antenna on it, and that is enough. We don't have a module with an antenna on it, so that's just because of the fact that you have to put an antenna is enough of a change that you then have to go through FCC testing.
Right.
But every region's different. Every other region in the world is different. So
okay, let me see.
Contact your own tax advisor to get to get that correct. And future history or past history is no guarantee of future performance. So
good. So we have a quick question, not necessarily a quick answer, but a quick question on a topic on Z-Wave in general, which is, would the Z-Wave routing protocol choose always a direct connection, or would it go through a hop of the quality if the quality was better?
So the Z-Wave uses what's called the last working route. That's its #1 choice. So however it got to that particular device, whether node 7 wants to talk to node 12, however it got there the last time successfully, it will remember that. Every device remembers how it got there, and it will always use that one first. Then there's basically a 5-step algorithm that goes through from there, depending on a variety of things. So it tries the last working route first, which works 99% of the time. If that fails, usually it tries direct. If it's known that that device is a neighbor, so that they are within range. If it knows that it's trying to talk to somebody that's in another building that's really far away, so I have to go through another node, then it will try that routing for choice first. It will try 4 other routes that it can come up with. And then the final choice is what's called an explorer frame, where it just it throws a broadcast packet out and says, help, I can't, for some reason, is anyone out there, can you forward this frame off to node 12? And odds are there is another node. That's the whole point of a mesh network. There's other nodes that will pick that up and say, hey, node 12, node 7 wants to talk to you. And then that once that connection is made, that becomes the last working route, and it will continue to use that route over and over again.
Excellent. Good to know. Another one, where do I get this documentation?
The documentation is in Simplicity Studio. A lot of the documentation is available on our website, but the best place to get the latest documentation is through Simplicity Studio. And again, that little trick where I showed you that if you enter the, so you don't even have to buy a developer's kit, you can just download the software, and then if you enter the ZGM device and then double click on the ZGM 130, then it will bring up all of the Z-Wave documentation for you.
Excellent. Okay, I got one last question. Unless anyone else has any more, please post them. What peripherals does the SDK use?
So the Z-Wave, actually, I'm going to share my screen again just for a second. Hopefully, let's see. I'm going to share this one, and then I need to bring up this document. So this is the data sheet for the ZGM 130. This is the Z-Wave chip. And these are all the peripherals that are inside of the chip, and they're color coded to tell you what power level the devices are still active in. So even if you're really, really asleep, you still have some pin wake ups and some cryo timers. And if you're only just a little bit asleep in what we call EM1, then the only thing that's asleep would be the ARM processor. But out of all of these peripherals that are out there, the only one that the SDK uses is what's called the RTCC, which is the real-time counter and calendar. That's required for the FreeRTOS. Basically, it's a 1 millisecond timer that's running all the time so that it can decide which task to run next. So that's the only peripheral that is dedicated to the SDK. If you're a battery-powered device and you use the application framework version of the battery command class, then the ADC will get used for that. And I thought there was one more. There's one or two other things that get used as well. The watchdog, so there's 2 watchdog counters. One of them is used as well, and then obviously all of the crypto things. There are 2 sets of crypto, so one of them is used for the Z-Wave encryption and decryption. So hopefully that answered your question.
It answered it for me. So if there are any other questions, we've got a bunch of compliments here, and Jimmy Austin, our friend, says thanks for good presentation. All right.
That's great.
Yeah, so anyway, I really want to thank you. This was a really very helpful presentation. Again, lots of compliments on it, and you can always reach out to Eric if they want to reach out to you. How should they do so, Eric?
Dr. Z-Wave at scilabs.com. So that's DRZWAVE or at scilabs.com.
All right, that's awesome. I just want to remind everyone that next week, we have the strategies for successful smart home product design and manufacturing with our friends from Leaderson. And meanwhile, listen, Eric, this is great. Very, very helpful and insightful. I want to thank you and thank everyone for coming and joining us. And please, we look forward to seeing you all next week too.
So
thanks,
when do you think the recording will be available?
Good question.
That's my question.
I would say just say yes, but I believe I need to get the answer from Janet, who's going to do the posting. Yes, I'm told tomorrow. All right, there we go.
Wow.
We'll have it tomorrow.
Okay.
How's that, right?
That's perfect.
Yes, because you did fly through it, and I know I need to spend a little bit more time pausing it and checking it out. So again, thank you so much, Eric, and everyone for joining us.
All right, thank you.